Hello, my name is Indiana Renfer, and welcome to PHYS 2212 Lab 3, Magnetic Fields of a Bar Magnet. In our table of contents, we have introduction, experimental data, computational data, and conclusion. The purpose of this lab was to observe and get a better understanding of magnetic fields. We'll do this by using a magnetometer app on our phone to track the magnetic fields of a magnet while using a ruler stick or ruler. We will track the magnetic fields based on distance and orientations along the north and south and east and west axis. Then we'll use glow scope to see how accurate our experimental data is. As a future look into my results, my magnetic moment was ended up being 3.84 times 10 to the 5, and the value of n I found was negative 3.6644. Important concepts, there's Vivit's law, its equation, distance dependence formula for a bar magnet, and a magnetic moment formula. Experiment details, initial conditions. Our initial setup was the phone with the magnetometer pointing north along the meter stick, so our exponent is 0. And we then placed the bar at the end of the meter stick. The system is the phone with the magnetometer, and the surroundings are the bar magnet and Earth's magnetic field on the magnet. Exceptions, we had to assume no matter how we orientate or move the phone, the Earth's magnetic field and the bar's magnetic field will have an effect on the magnetometer. And the steps to the lab went like this. We set the magnetic leader aligned to the north and south axis. The north component is 0. And then we placed it on the meter stick and we placed a line of tape on it. And then we rotated it 90 degrees on another tape. So we always be proportional to the meter stick. And then we would move the phone along the meter stick to see how the distance of the magnetic affects the magnetic fields. And we found as the magnetometer moved closer to the phone, the fields were greater and the distance was smaller. And then we would find this magnetic distance at B net 100. And at that distance, we'll move it up to create a 45-degree angle and find the XYZ components and find the overall net magnetic field. These are the results. These are the different distance at 20 meters, 70, 120, 170, 22. We were looking for values of these, and we found the average. Then we did the off-axis field where we found the B net 100, and there's like Earth. Then what we measured the distance and corrected T, and these are X, Y, and Z, and our overall B net. We found it to be 64.53. And then you can also see the dependence formula here. Observations, calculations. I found my dependence equation to be y equals negative 3.6944x minus 2.5667. This makes the slope negative 3.69444, which ends up being n based on the formula here, which make k equal to 7.68 times 10 to the negative 2. When using Vivit's law, finding the magnetic moment formula earlier, we then use define mu by plugging into the equation earlier, and to find that our magnetic moment was 384,000. We can already start seeing there were some problems in the experimental, but we see more of that right here in the computational data, where we apply our physical contents of the magnetic constant. Then we plugged in the magnetic field at the origin of the magnetic moment, and we created a function for the magnetic field, and then we scaled some arrows to see how the magnetic field acted overall. And then we did like dperp to find our off-axis, which we found the 45-degree, and then our magnetic 45-degree. And then overall, we found these locations and then our net at the X and Y. And we can already start seeing a difference where it's 0.9 and then 2.96. And here they are right next to each other. The computation was here and the experimental here. We can tell that some possible errors of error. I possibly turned the phone, rotated a little bit when moving it along the meter stick, which made some misleading results. And then I used I off the graph instead of estimated results for like simple. And then there's also, I miscalculated the distance based on the ruler I was using. So there's a possible source of error why our B net is much larger than what the computational glow script found. An overall conclusion, what if you hadn't rotated your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect the Earth's magnetic field, how would your results have changed? Our results would have been vastly different. Our numbers would have included the strength of the Earth alongside the magnet, making the numbers on the x-axis much different, possibly larger, and then resulting in the x and z values being smaller. And what if you were to stick the two identical magnets together in the end and run the experiment again? How would you expect the measurements to differ? I think everything would just be factored by 2. Thank you, and I hope you guys have a great day.